Okay, CCP College Algebra, also known as Hey Caitlin. Here's your video for March 17th, March 18th. It'll cover a couple days worth of material. What we're going to do is we're going to jump right into Chapter 4, Section 1. Okay. And we're really going to just focus on page. Let me try to write with my stylus. And, because I buy one and it don't work, we're going to go to page 449 in your book. Okay. We're going to talk about compound interest. And I'll just briefly go over what sections or what information you need to look at. Okay. So, sorry, my son decided to eat hot dog and play on the iPad, and he's got hot dog gunk everywhere. I don't even know why I'm writing intercept. This is a good start. Good start to a good video, right? Alright, so compound interest. So go to that page in your book and we'll kind of talk about what to look for. Okay? There's some formulas that you need to visit, and I'll just read along and go from there. So make sure you got your book ready before you dig into this video. Alright, so if you look at the bottom of page 449, you'll see compound interest, what the variables represent. So when you look at the A equals P plus PR equals P parentheses 1 plus R, we got to understand the variables that are within that formula. A represents the accumulated value, because we're actually putting into the formula the principal amount, and that's being calculated with the interest that is being gained. So P represents the principal, which is pretty much, it is the money that is invested, or whatever is invested into the to the account. R represents the rate. Now I'm going to tell you, because I know how people overlook this, and I'm just going to give you a fair warning. The R, okay, that's going to be given as a percentage. That percentage needs to be in decimal form. Okay, if you see a percent sign in that rate, which you will, okay, write it in decimal form. Alright. The table 4.3 at the bottom just kind of shows you how that formula was developed, and over a course of time, you'll see at the very bottom, you'll see this formula. Okay, now this formula, if I can write it, A equals P, and then parentheses 1 plus R, and then T is an exponent. See, we're dealing with exponential. T is usually in form of time, and that is in years. Okay. This particular formula is when you are compounding annually. Oh my goodness. I can't spell, can't write. This is all working out pretty good, isn't it? I'm going to try this again. I'd probably waste more time yammering. Annually. Okay. So the T is in years. Okay. Rate, make sure it's in decimal form. Principal, P, that's the amount that you invest. And when you plug P and R in and T, that will give you the amount, okay, that's been accrued. Okay. If you go back, A is the accumulated amount. Okay, that's a formula for annually. Now what I want you to do is go to the very next page. Okay, we're going to add some things in there. There is some compounding and different types of compounding, and that's going to change the formula just a tad bit. So what I need you to look at is on page 450, and there's a table 4.4. Okay, that table is a good guide to discuss, or not discuss, but kind of help you with what if we're compounding quarterly, semi-annually, monthly compounding. If you look, semi-annual compounding is twice a year because the length of each compound period is 6 months. Now here's how they came up with this. Okay, if you think every 6 months within a year's time, it's being compounded twice. That's why you see that N equals 2 when it's semi-annually compounded. Okay. I actually had a lot of people in the past few years not understand that. Quarterly. Okay, when you think quarterly, that's every 3 months out of the year. So how many times is it getting compounded? 4 times per year. Okay, that is quarterly compounded. Okay, monthly. Well, there's 12 months in a year. So obviously N would equal 12. Alright. So, that's pretty much once a month. Now it's really wanting to write. Okay, so pay attention to the language. If it's just being compounded annually, there is no N involved. But when you're compounding several times in a year, whether it's 2 or 12, it changes that formula we dealt with. So let me give an example here, or what the formula looks like anyway. The formula kind of transforms a little bit. We have P, there's our principal amount. There's our principal amount. Then the 1 is still there. But now we got to take that interest rate. Here's where it gets kind of tricky. We're going to take that interest rate that's already written as a decimal, and we're going to divide that by N. However we're compounding it, whether it's semi-annually, quarterly, or monthly. Okay, if it's compounded more than once a year, you're going to have to use this formula. Okay, now here's the even trickier part when you punch it in. Okay. everything's raised to the n times t power. Okay. Now, going beyond this, where I'm looking on the same page, okay? I'm looking on the same page. There is such a thing called continuous compounding, okay? And that one is actually the easiest formula. If it's continuously compounded, where the number of compounding periods increases infinitely, okay, like every trillionth of a second, every quadrillionth of a second, okay, that formula we just talked about takes on a whole new shape, okay. So here is continuous compounding. All right, so the formula, it still has the amount accumulated equals our principal amount, but because everything is becoming more and more, it's continuously just accumulates. It compounds interest every so often that it gets out of hand. So you got to work really exponentially. So we're going to use E. Okay. I'm guessing you recognize that. If not, we will discuss it in a later, or we'll just discuss it. Continuous compounding, the formula is just A equals P times E to the RT power. Okay. So I will do checkpoint 7 real quick. Let me see how much time we have in the video. I really can't tell until I get to it. Okay, I had to hit finish recording. Tell you what, we'll look at checkpoint 7 real quick. And tell you what, I'll hit pause and I'll start working on it, and then see what you can come up with. So I'm going to hit pause. I'll be right back. Okay, so there's what I came up with part A for checkpoint 7. I'm just looking at part A. A sum of $10,000 is invested at an annual rate of 8%. Notice that I put that as a decimal. Find the balance in the account after 5 years. So, I'm using that formula we talked about a couple slides ago. Okay, that one right there at the bottom. Okay, it's being compounded quarterly. So I'm going to use n equals 4. Okay, and then using that formula again, I got 4 times t, which is 5. We're looking at 5 years. Okay, so on the calculator, sorry, I'm everywhere. Oh, it's so slow. Okay, so on the calculator, we'll just punch in that right there. So I will hit pause again. Alrighty, so that's how I would type it in. Go back. The only thing I did different was I multiplied the 4 times 5 as the exponent. And this amount here, the $14,859.47, that would be the accumulated value. It's simple plug and chug. You just got to pay attention to what kind of situation you're in. Now, let's go to part B. Give me a second. I'll get it set up and go ahead and plug it into the calculator. Alright, so I punched it in, and I got the accumulated amount of $14,918.25 because you want to round to the nearest cent. Okay. Here's what that looks like if you set it up on your own. Pretty simple. I got my A equals principal times E to the 0.08 times 5 power. Okay. You can actually just type that in. To type that in, I'll go back and I'll show you how to type it in. Start off with the 10,000 times. Okay, follow the buttons that I push. You gotta hit second LN. That stands for natural log. So we're doing second LN. It brings up E. Okay, then just type in your exponent, which is that, and tab out. And you get the same thing. Okay, so I'm going to give you a set of problems to work on for the next day or so. And then we will chat about it in Google Classroom Thursday. So stay tuned, stay healthy, be safe.